Hello everyone, and welcome back to another episode of Index for Office Hours. Today is the 11th of April, and this is 102, IOH 102. That is insane. We crossed the 100 mark. It is certainly a huge milestone. So, as I normally do, I'm just going to give my normal introduction. So if anyone is new to Index for Office Hours, this is the town square for graph ecosystem participants to come together and to discuss the most important and relevant topics for the Indexer community. This is a conversation, so we'll be breaking out into various different topics, and at certain points we'd love to have your contribution. And so if you'd like to mention anything, please do via the text box in the corner, or by trying to unmute your mic. And if you're having issues there, please do let us know, and we can get that sorted for you. As a reminder, this session is recorded and will be distributed onto public channels like YouTube. So if you're concerned about privacy, please bear that in mind. And with that, let's get into today's exciting agenda. Opening remarks, and I will give a shout out to the 𝗨𝗀𝗂𝗧𝗂𝗧 podcast, for episode 111. They've also passed the 100 mark. It's insane to fathom. But this one was with Vincent, and Vincent is a Web3 full stack engineer at Superfluid. And for any of you who don't know what Superfluid is, it's effectively a way to stream money on blockchains. I think it's actually quite a fascinating protocol. If you're interested, I would definitely recommend checking it out. And then in this particular episode, Vincent and Nick spoke a bit about the background of Vincent, how he studied computer science at university and his transition into Web3 and smart contracts. They speak a bit about Superfluid and the way that it's planning to revolutionize the way that value is transmitted on blockchains and hopefully all types of payments. He also discussed his journey of joining Superfluid and also, of course, the importance of the graph and how Superfluid is leveraging the graph. So if you're interested in both Superfluid and learning a bit about Vincent's background, Nick is a fantastic interviewer. I definitely recommend checking that episode out. And let me just grab a copy and put that in the chat here. Oh, Nick's already done that. Fantastic. As always, ahead of the game. Thank you so much, Nick. And then I'll hand it over to Anna, who's going to take us into Repo Watch.
Thank you, Abel, and hello, everyone. Today's Repo Watch is ridiculously light. We only have 2 releases, so we're going to fly through it really fast. So on the execution layer client, we have had a new release for Firehose ETH. This is version 1.3.8. So this is a bug fix release for all node operators that are about to upgrade to Shanghai release. The Firehose instrumented yet compatible with Shanghai release introduces a new message called cancel block, and it seems that this causes, in some circumstances, a bug in the console reader that was causing a panic, but actually no block was actively being assembled. So they have fixed that issue, and what you need to know is that there is no need to update Firehose instrumented yet binary code. You only need to update Firehose ETH, which needs to be bumped if you're already, which only needs to be bumped if you are already at the latest yet version. So that's one release, and then the other release we have this week is sorry, 1 second. I have lost it. That's the only release we had this week. Does anyone have any comments, or would anyone like to share anything about the repos, or if anyone has tried Firehose ETH new version? Okay. If not, I will hand over to. I
Me.
don't see. Yeah, there you go.
Yeah,
Um,
Juan is not here today.
okay, yes, Abel. Thank you.
Amazing. Thank you so much, Anna, for the Reaper Watch update. Cool. Well, I will be doing Protocol Watch today. This is because Juan isn't here today, so let's see if I can do as good a job as he usually does. Um, So for forum governance, oh yes, before I get into it, it's always good to share the agenda just so you guys can follow along, as a lot of the information will be in the agenda there. So forum governance. So GIP 0051, which we will be discussing today, is exponential query fee rebate for indexers. So it's a long proposal, very in-depth proposal. I love these proposals that really go into detail. It's super fascinating to read them. But if anyone wants the high level, this proposal is effectively suggesting replacing the graph's current Cobb-Douglas rebate mechanism with an exponential rebate function to fix a lot of the issues that people have rightfully discovered with the current Cobb-Douglas rebate mechanism. The new mechanism, for additional context, effectively removes the need for indexes to predict other indexer stakes. It also simplifies the optimal decision in terms of staking, like what the optimal amount should be. And it also reduces frictional costs related to serving queries. You can learn a bit more about all of that in the particular GIP, which I'll actually go ahead and link because it's particularly relevant in today's conversation. So there we go. Feast your eyes on that bad boy. And then we go on to forum research. As always, the core developers have done a fantastic job of keeping us up to date with all the great things that they're working on. Streaming Fast, GraphOps, Semiotic Labs, The Guild, and Edge and Node have all posted updates, which are in the forum research section of Protocol Watch. Something that we'll also be talking about today is the quality and cost of service Oracle for. That's something else. We'll be talking about QoS data, and so there is a note in here about that, but obviously we'll speak a bit more to that later in today's conversation. And then all of the contracts, as you can see in the agenda I've linked, there's a bunch of updates. And then as it relates to network subgraphs, no new updates since the last IOH. So there you go. I hope I did a good job. Juan is a lot better than I am, but hopefully that should suffice. If I'm not mistaken, I can't see Pedro, so we are not doing any MIPS updates today, but there's obviously been an email, so everyone should have the updates in their inboxes. Today, I'm very excited to have Craig. Oh, Nick, I see you typing. Maybe you have some things to share. Would you like to take the mic? Okay, got it. I've just seen the text. Fantastic. Cool. Well, the next section, yeah, I'm very excited to introduce Craig and Ricky, who have kindly decided to join us today for IOH, talk to us all about QoS data, something that we've been thinking a lot about here at IOH. Every one of you here are active participants in the ecosystem as indexers, and obviously, we want the graph to be a viable solution for anyone wanting to use blockchain data. We need to have a high level of QoS. So without further ado, I would love to introduce Craig and Ricky to speak to the topic.
Thank you. I'm going to see if I can share my screen here, if you'll just give me a second.
Yes. It hopefully should work, but if you have any issues, please do shout and we can get that sorted for you.
Anyone see yet or no?
Not yet, no.
Okay, what about now?
All right, something seems to be loading, which is a good sign, but don't see anything yet. But hopefully, after a while, we should see something. There we go. Fantastic. All working.
Okay, great. Cool. Yeah, so my name's Craig. I work at Edge and Node in data science with Ricky. Yeah, so we recently produced an Oracle to provide more information about the cost and quality of service um, on the network. And we're pretty excited about it and excited to get the data in your hands so that you can, extend its use to different types of applications, use cases, dashboards, real-time dashboards, etc. Um, so yeah, so I'll just give a little background on the architecture itself, and then can go into some of the metric definitions and some of the ways that you can use the subgraph that Juan produced. So as people are aware, we have clients. They make requests to gateways. The gateways forward those requests along to indexers, which is you all. You send the response back to the gateway, which sends it back to the client. So in uh, any gateway deployments or all gateway deployments, we have a log producer that sends some metadata about queries such as the latency to and the query fees to a streaming cluster, Red Panda streaming cluster, which is Red Panda is a Kafka compliant streaming data platform. And then we have a streaming database called Materialize that takes these log records and then aggregates them into aggregate statistics at the indexer and subgraph level. So we can see what the typical latency is for a query on a subgraph for a given indexer, or the cost, things like that. So we have that running, and what the Oracle does, it starts here, and it's just a cron job that queries data from Materialize, which is aggregated in real time from those gateway logs, and it will produce stats. So we were doing this every minute when we started, but now we're doing it every 5 minutes. So it will aggregate for each indexer and each subgraph how many queries did the indexer serve on that subgraph, what was the latency, what were the query fees billed, and it will post that as a JSON flat file to IPFS, to the graph's IPFS node. And this can then be picked up in a subgraph, these IPFS files, because we are sending an on-chain transaction that to a data edge contract that just posts basically the IPFS file hash, a topic name, which in this case is we have two topics right now, but gateway indexer attempt, quality of service, 5 minutes, so it's like super long. But yeah, we have two topics basically. We're sending the file hash to Gnosis chain, which is very cheap, and so anyway, those transactions can be picked up in the subgraph. It knows what the IPFS file hash is, and then the subgraph can go and fetch those IPFS files and index them. So then we have a nice subgraph at the end of the day that has like some daily statistics, or you can just see a time series basically of quality service, cost of service, query volume, things like that. So yeah, that's the architecture. And I can go over some of the metric definitions for the two topics that we have here. So yeah, anyway, you can see the contract interactions here. Can everyone see this? You still seeing the window?
You're still on Notion, right?
No. Okay, I see. Yep, let's see. 1 second. Okay. All right. So this is the contract address on Gnosis chain. Can everyone see this now?
Yeah,
Okay,
we can see it now. Thanks
yeah,
so much.
you can see it. You can see every 5 minutes, basically, there's a contract interaction. You can look at the transaction and decode the data here. And you see the topic. This is the file hash. This is the timestamp that's being covered in the data. But yeah, and these are super cheap, less than 1 cent. And let's see. So we loaded this with this address with $50, and we've had 111, almost 112,000 transactions for less than $14 so far. So very cheap to post the data, and then it's available, can be indexed in the subgraph. Okay, so now what data is available? So we have 2 topics. The first is the indexer attempt topic, and these are the attempts that gateways make to indexers. And the fields available, we have the indexer wallet URL. Everything comes from like on-chain sources for that. And we have like average query fee, max, total query fees, query count, average latency, max latency, 200 responses received from the indexer, the proportion of 200 responses, which typically corresponds to a success, though not always. The average blocks behind that the indexer was from RPC nodes at the time, max blocks behind, and then standard deviation of the latency. So typically people will report latencies as percentiles because outliers can warp the average, can skew the average, but in our case, Materialize doesn't support percentile metrics yet because it does everything in memory, and it's like it's very expensive to compute percentiles in that way. So it doesn't support that yet, but it can update averages very efficiently. So we just have the average and the standard deviation basically for now until that's supported. Yeah, so that's the first one, and the main difference here is that this one has the indexer level and the subgraph deployment level, so it's at 2 levels here. Also have the chain, the gateway ID, etc. Okay, and the second topic here is query results, and so instead of like the requests that gateways make to indexers, this is you can think about this as from the perspective of the user. These are requests that users make to gateways, which then are sent to indexers according to the ISA, the way that dispatches the queries. So this is more like what the user would see, and so this would be the latency that they see as opposed to like the latencies that the gateways see. So again, we have, this is just at the subgraph deployment level. It's aggregated at the subgraph deployment level. We have the chain gateways, gateway IDs. And, start epoch, end epoch is like just the 5-minute window over which the observation is occurring. And basically the same metrics for this, query fees, query count, number of queries, most recent query success rate, which again is in this case we actually net out user attributed errors. So there like we can have errors where someone just sends a bad query, and we don't want that to count against like any sort of success rate metric. So we net those out, but then you can back those back out if you want to here. But those are user attributed errors. And then we have the same latency metrics. So this is an example file, IPFS file that's posted to our subsidized IPFS node. So that's what it looks like. It's just a JSON file. Oh, can you see that? You can't. This is a sample file. It's just a JSON file with the stats for those 5 minutes. And then
Yeah, we get to see it now.
Okay, cool. And then yeah, so that's really all there is to it. We use 𝗨𝗀𝗟𝗶𝗀 Defender, Auto Defender for the on-chain transactions. That makes it super easy to secure the private key and also just like to post that data. So that's pretty much all there is to it. And so Juan has created a subgraph that indexes these IPFS files. I created a shell subgraph, which can be forked, but that's basically just to get these data edge contract events in the metadata. But Juan created a subgraph, which is a lot more feature rich. And this one, I'll show you. So this one will you can query for like daily stats and things like that, but it's the MIPS Oracle. There we go. So you can do basic stuff like just get the payload, but then you can also get like these data points, daily data points as well. So there's that, and that code is open source. So you can see that and fork that, or you can just use the subgraph as it is to create dashboards, etc. So we're definitely very excited to see what the community produces. Ricky's already produced a dashboard, which I'll stop sharing here and let him show, some of what you can do with this data and what he's already done. But this is the subgraph here. This stuff is all linked in a forum post that I made a few weeks ago. So I'll paste that forum post in the chat here. But yeah, I'll hand over to Ricky now, and and then we'll be happy to answer any questions.
Perfect. Sounds good. Thanks, Craig. And yeah, great to be here. Let me share my screen. Okay. I think this should be right.
Yes, we can see it. Thanks.
Okay. Sorry, let me just check my mic. You can hear me fine, yeah?
Yes, loud and clear.
Okay, perfect. So yeah, basically, as Craig mentioned, this is essentially just like a public-facing dashboard, which ingests data from the subgraph and like the process that Craig described. You definitely, don't need to, use this. It was just something we made to help support the MIPS program, so indexers could essentially look up their own stats during the program more easily rather than, creating their own dashboards. But we would love to see, indexers or whoever else in the community create dashboards analysis. So yeah, really looking forward to just jump into a demo here. So as I mentioned, one of the use cases here was for MIPS. So for example, let's say, I'm an indexer and I want to basically look up some of my stats during one of the older MIPS phases. So I could essentially adjust these filters to get down to the data I need. So what I'm going to do here is I'm going to adjust this first filter. And let me maybe zoom in a little. Let me know if it's not zoomed in enough. So in here, I can switch this over to basically populate a list of subgraphs. Okay, great. So essentially, choose the data I want from like the subgraph I'm interested in. So if I'm looking for a Goerli stuff from an older MIPS, I can change this first to Goerli. Then this list of subgraphs should auto-populate. I don't know why. Okay, there we go. And I'm just going to change this to MIPS. or just any MIPS one, just as an example here. Or I think my whiting a bit slow here. Just give it a second. Okay, so as you can see here now, we have basically daily data for each indexer, essentially, for that subgraph, and we basically have easy access to like all those fields that Craig was mentioning. And there's a button here where you can easily download the CSV. You have a lot of participants in MIPS, so it kind of gives you this stacked bar chart of like the query count as a whole. And then I can do things like I can change this maybe to a pie chart, for example, and it's going to show me for kind of like the given period of time, like what percentage of the queries was served by what indexer. So this does look really messy because, as I said, we have a ton of indexers on this one given subgraph. But then you might be interested in your own data as an indexer. So what I can do is I can go down here. Again, this is still going to be on the same subgraph that we chose before, but now I can basically select a indexer that's supporting. So this list here is also auto-generated based on the subgraph selection. So these are all the indexers that are on the subgraph. You can select any of them, and you can essentially, you have the data here, the daily data. And then you can download a CSV file, and kind of a similar thing here with the visualization, where you can kind of, maybe look at the blocks behind for this indexer, and kind of look at what that looks like. So yeah, that's just kind of a quick demo. Again, definitely not something that you need to use. We definitely encourage people to kind of create their own solutions. The code for this is open source. I'll add it to the chat here. So feel free to fork it. This is written in Python using Streamlit, so it should be pretty straightforward to fork. But yeah, I think that's essentially it. So yeah, if there's any questions.
Fantastic. Thank you so much there, Craig and Ricky. We got a question here saying when Phantom data will be in Streamlit. But I think, yeah, I'll let you answer.
Yeah, that's a really good question, actually. Yeah, so at the time, so I wrote this, about a month ago. So at the time, we didn't have, there were a couple things that I didn't include at the time. So that's a really good note. Yeah, there are things that may be missing from this. So I'll try and kind of do a review this week. So by end of week Friday, everything should be in there. But it would be great if anyone wanted to fork it and like create some other version. I'm sure it should be doable. So basically the data in the subgraph itself should be there. Actually, that actually reminds me of something I missed. Let me share my screen again. So if a subgraph is missing from this list, one thing you can try is you should be able to just enter your own IPFS hash in this box here, and it should basically override the subgraph name. So if it's not being populated, I would try that. But yeah, basically just reach out to me if you're having any issues not getting the data that you need, and I'll make sure to add that in right away, because we really haven't gotten much feedback, much real kind of real world feedback on this. So yeah, please reach out with any things that might be missing here.
Wonderful. Thank you so much for answering the question and adding additional context there, Ricky. Anyone have any questions in relation to everything that was just shared? Feel free to either comment in the text box or unmute your mic. I see a few people typing.
Yes.
Sweet.
The logs are from all gateways currently, but not guaranteed that all future gateways will send these along. But we're hoping to establish that as a standard. I'll add there are a number of disclaimers on the end of the developer documentation there. So data isn't like, this is still like an alpha release here. So we don't guarantee like the availability or the timeliness of the data, or, it's not deterministic either. So, use at your own risk. But yeah, we're going to try to improve on that stuff over time. But if you notice that like the job is down or data isn't coming in, just let us know, and we can look into that to triage. Yes, there is a gateway ID field. So there are multiple gateway deployments that are sending data in currently. Yes. You can break that down by the gateway ID. The other thing I'll plug is we're also interested in just this general usage pattern for the graph. So like the idea of having a Web3 data pipeline where more complex computation will happen off-chain, but like an Oracle will post it on-chain to IPFS, and then the data will get indexed in a subgraph. We think that could be a pretty powerful pattern for building more complex or like personalized applications. So if you have any ideas with that, definitely let us know. We're interested in kind of promoting this as a way to avoid having the development operations cost of running a proprietary API server when you can just have a cron job that kind of uploads the data and offload that work to indexers.
Great stuff. Any additional questions on this topic here? If not, I want to thank. I see Vince typing, so I'll let Vince finish. Haha. We could do that. That could be a thing. If people are interested in a Shanghai watch party, can you put a plus? Let me just do a plus. If you can add a plus to Vince's comment there, and if there's sufficient demand, I think we could definitely entertain that. I think that'd be fun. Thanks for suggesting, Vince. Cool. Well, thank you everyone for engaging in that topic, and thank you especially to Ricky and Craig for going into detail there. We think QoS is super important. We want to keep an eye on that as indexes in the ecosystem and try and make it as best as possible. So yeah, thank you guys. And as they've so kindly done, they've linked everything here. So if you'd like to go into this further, you should have all the links required. We're also going to have some sort of like network watch segment that we've been speaking about that for a while, and so that will be coming up very soon. Keep your eyes peeled for that. Great. Well, next section, I think we're very fortunate to have Howard, Justin, and Tomas with us, who are going to talk about the JIP that I referred to earlier. If any of you, JIP 51 that is, if any of you want to kick off, feel free to unmute your mic and get straight into it. All right, I can see that Justin's unmuted, but we can't seem to hear him. Maybe he's having some audio issues. Do you want to try and see if you have push to talk enabled, Justin? That's usually the issue. I see Howard. Yeah, Howard's typing. Justin, we can't hear you. Yeah, that's right. It says push to talk limited. Okay. Okay, I'm going to work with Justin to try to get that sorted out. But Adam, if you could do maybe a little primer on the JIP while we're getting that sorted, that'd be fantastic.
Sure. So yes, I guess drawing attention to GIP 51, so exponential query fee rebates for indexes. So firstly, I'd really encourage people to check it out on the forum. Thanks so much, 𝗨𝗂𝗟𝗶, for sharing the link. This maybe has sort of quite an academic name, but this is actually a pretty broad sweeping GIP, which I think is really exciting in terms of improving legibility and making decision making much easier for indexers, and just generally making sort of query fee collection simpler and more straightforward. So this is essentially replacing the current rebate mechanism, which is based on 𝗨𝗀𝗟𝗶 with an exponential rebate mechanism, which essentially will make it much easier for indexers to be able to tell if they're like how much of a rebate they'll receive, and therefore makes it easier to make staking decisions. And so that's sort of a lot of the motivation. Essentially, the only thing that will matter when it comes to query fee rebate will be the ratio between an indexer's stake on a subgraph and the query fees that they earned. So two numbers that is much easier to reason about. And essentially, staking more relative to query fees will result in a larger percentage rebate of those fees, with essentially for sufficiently large stakes receiving like all of the query fees generated. So there's then I guess more detail in the GIP for folks to jump into, but broadly speaking, I think I'd encourage people to firstly ask questions here if you have them. If you don't have questions which immediately come to mind, really encourage people to go to the forum, go to the discussion, and post anything from sort of clarifying questions, sort of any alterations which you'd recommend, or things that you're not sure about from the GIP, because yes, certainly from our side we're pretty excited about it. I want to make sure that it gets broad coverage and folks know what is being proposed. I don't know if people are familiar with it, or if Justin has managed to get his technology working.
Let's see, Justin, how you doing? Oh yeah, Howard's asked me to share the presentation, which I can do. I will do that right now. Just bear with me a second. Okay, how about now?
Yeah, there we go.
All right, fantastic. Thank you.
So, okay, exponential query fee rebates. So essentially, as Adam said, this GIP, what it does, it proposes to remove the current 𝗨𝗀𝗟𝗏 based formula. There's a couple of reasons why we want to do that. First one being that since the formula takes into account like not only your stake, but like the stake of the network, it means that the amount of fees that you get as an indexer is dependent on others, which makes first very difficult to calculate that beforehand without actually claiming your fees. And it also means that decisions that other indexers make impact you, and which intuitively that shouldn't be the case. So the idea is, again, to try to simplify this process and make it as straightforward as possible for indexers. Like, if you are generating X amount of query fees, ideally you get that entire percentage of fees to you because you generated them. Again, there are some factors that we will see that can affect that, but essentially those factors will only depend on you as an indexer and variables that you can control, and there will be nothing outside of your control that can impact you. That was the main motivation behind this. It's derived from that, but with the current mechanism, I don't recall the exact numbers, but I think somewhere close to 60 to 70% of the query fees were getting burnt because the way 𝗨𝗪𝗪 works. So that's another thing that we wanted to address and to fix with this new mechanism. Query fees are really the reason why the protocol exists in the first place. So you want to serve queries for the user and you get paid for that. So burning query fees doesn't really make much sense. So as a mechanism that has a very high burn rate is not ideal. So yeah, these are the things that we that I had in mind when trying to find out a new mechanism that was better. You can go to the next. Okay. And that mechanism that Howard and Justin found and proposed is called exponential rebates. It's basically, I think in the next slide there might be a. Can you go? Okay, no, go back. Sorry. So the exponential rebates is basically an exponential formula where. Hold on a second. Okay. So it's an exponential formula where the variables that affect what's the percentage of the query fees that you generated are essentially your stake and the amount of query fees that you generated. So those two values are under your control. As we said, this removes the dependence from other indexers, and it also makes it very predictable to know how much you're getting out of the amount that you are generating. The formula has a couple of parameters that the proposed values that we have for that make it so that there is a very little query fee burn, which is one thing we wanted to incentivize. Let me check the numbers, but one sec. So Howard, I think, did the math, and if you take into account, like from protocol genesis until now, using this mechanism would result in like 5% of the fees burnt, compared to that number I said earlier, like 50 or 60% of the query fees that are burnt using the 𝗨𝗪𝗪 mechanism. So burning less fees means more fees are distributed to indexers, giving the indexers a more predictable way of knowing how much they're getting. It's also a benefit. So those are the main characteristics we wanted from this. And if you can go to the next one. Yeah, so here is the actual formula. It's maybe a bit on the mathy side, but it's fairly simple. If you look at the first line, it's R is the amount of the rebates, so the amount of query fees that an indexer gets for any given subgraph. Q is the amount of query fees generated, so the amount of fees you're getting is the amount of fees you generated times a factor. And that factor is 1 minus an exponential. The way the math here works out, if you take a look at the exponent of the exponential, you have the stake, what we're calling the stake ratio. So stake over the fees generated. And the way this works is if you have, let's say, a high amount of stake relative to the fees you're generating, let's say you can approximate this exponential as a exponent as a very big number. So that means that this entire factor is close to 1. So if you are on a ideally in an if you take this to the limit and you have enough stake, you can consider as if the fees you're generating, that you are capturing them in their entirety for yourself, and there's very little that's actually being burnt and lost. Of course, there are these alpha and lambda parameters that there will be set by governance, and they can be adjusted if needed. But the main levers, I'd say, to control this formula are, again, this what we call a stake ratio. And that's entirely under the indexer's control. I think there's one more slide, maybe. Yeah, I mean, this is the again a chart of what the formula looks like for different stake ratios. So for a sufficiently large stake ratio, you can see that you can approximate the proportion of rebated query fees to 1, which means that you're getting all the fees that you are generating. So provided that you have enough stake, you will be capturing all the value that you are generating for the network, which is the effect we were looking for. And I think that's pretty much it. There are several, I would say, simplifications that come out of this proposal. For instance, implementing a proposal like this means that we no longer need rebate pools. They are no longer needed. Rebate pools are needed currently because we need a bucket per epoch where we collect all fees, and then we apply the 𝗀𝗪 formula to that. Since we need this bucket because we need to the 𝗀𝗪 formula takes into account the state not only of the indexer but all the network. So you need to collect and then claim the query fees. This is no longer needed, so rebate pools are no longer needed. That simplifies the contracts, the code a lot, but it also means that in order to collect fees, you won't need these 2 stages where today you first call a collect function or a redeem function, and then that gets put into the rebate pool, and later on you can call the claim function, and then you get the fees. From now on, you will only have a single operation. Let's call it claim, collect, or whatever. Then you call that function and you immediately get the fees that you are owed. So that's a nice side benefit of this change as well. There's several code simplifications lots of code that we can remove from the staking contract, which is always nice to remove code. I think there are some questions. Oh, Jim makes a good point. There is I think you're referring to the channel dispute epoch. I think you are. The channel dispute epochs is like a window where once an allocation is closed, then you need to wait a certain period of time before you can claim the voucher, before you can claim the rebates for the vouchers that you have collected. This won't be needed anymore going forward. There are some nodes regarding this for the transition period. One of the challenges of this GIP is the transition from one model to the next one. And there are some nuances to that I've described in the GIP. I think it's a bit too much to cover now, but if you are interested in that, I suggest you go take a read. We will be initially reducing that dispute window from 7 days to the minimum, which is 1 day, to give more flexibility. Before that's going to happen before the upgrade, or that's what we're proposing. And eventually, with this upgrade, the channel dispute epochs will no longer be needed. So that's going to go as well.
Yes, yeah, that was just a typo on the slide, which I think, yeah, I was just clarifying in the comments. But yeah, thanks so much, Tomasz. That was yeah, great overview and yeah, great job jumping into slides you hadn't seen before there.
I just want to clarify one thing. Maybe I wasn't clear. The dispute epoch, the channel dispute window is needed today to allow this time where this two-step collection, I'd say, where you first collect vouchers and then you claim the rebates. Since going forward we will have like a single operation, this window is not needed. I don't know if I explained that clearly before, but that's the reason.
I thought the dispute window had to do with the correctness of the data that we served. So I don't quite get why this new system we wouldn't be liable anymore to data correctness being served.
No, that's another window which is related to arbitration and POI challenges. Is that what you're referring to? That stays. That has.
Yeah, the proof of indexing is about the correctness of the data that we index, but there is the other kind of slashable offense that, you know, if we serve data that is incorrect, there is also a potential to. I don't think we've actually seen any disputes on queries itself, but yeah, in my head there was something that, okay, we are also liable and therefore need this window for the queries itself that we serve, not just for the data that we are storing.
Yeah, no, that's correct. The arbitration windows, those are staying. This dispute, unless I'm mistaken, this is a separate consideration. So that's, I mean, you will still be able to challenge. As you say, we haven't seen any query challenges yet, but that will remain unchanged.
It seems like we've got another question from Derek saying, if we were to exclude 1GRT allocations, do we know how many allocations we're not at? How many allocations we're not at a 10x stake ratio?
I think I would say that there's intention to come back to Indexer office hours in a couple of weeks. This is just an initial presentation to sort of see the topic, and yeah, we can maybe get into those greater details then, Abel, if that makes sense.
Yes, it does. Yeah, we spoke a bit about this. Yeah, that, as Adam said, we are thinking about potentially, maybe the 25th as the placeholder date. But yeah, certainly want to loop back on this because it's something that's very important for the index community to, be fully aware of and engage with as we transition. And I'm going to post the forum post there as well. So Derek seems to be pretty engaged in this. So if you could post those questions and you guys go back and forth on the forum, that'd be great. Yeah, amazing. Thank you so much, Derek. Great. Well, I think that was a really good section. Thank you, Thomas, for stepping in there. I think you did a fantastic job, despite not seeing the
worries.
The slides there. So thank you, buddy. And yeah, thank you as well, Justin, Howard, Adam, for all contributing, and thank you all of you for engaging in that conversation there. Another packed episode. So thank you everyone for hopping in. Great. Thank you so much for posting your email there. That's very kind of you, Justin. Another fantastically packed episode. I learned a lot, and I hope you guys did too. Special thank you to all of those who spoke today and engaged and shared with the community. And thank you all of you in the community who showed up and engaged with today's conversation. Looking forward to doing this again next week. We have David Lutter from Edge and Node, who is a very highly requested person who's going to be sharing some amazing stuff with us next week. So keep your eyes peeled for that one. Thank you all, and I look forward to seeing you all again next week. Take care, everyone, and enjoy the rest of your week. Bye-bye.